Hello, everyone.
Hi, Professor.
Can you guys hear me?
Yes, I can hear you.
Okay, great. Okay. Okay, so I'm waiting for more people to connect. So there's a few people right now. So so I'm gonna wait for some people to connect. And while I'm waiting, if you have, before I describe the exam, if you have any other questions, you might want to ask. I want to go over a few things. I guess I can take this opportunity. So, so one thing is while we're waiting, seen it already. So we'll be using email for communication and this medium, Zoom, for the class delivery. I will be recording the videos as well and posting them on the YouTube channel. Remember the website here basically provides a lot of details that you can use. Remember, I created a calendar here, and so I've linked videos. So hopefully last week you had a chance to look at the convolutional neural network videos. So please take a look at that. All right, if you haven't done so already. And today we're gonna have our midterm exam. So I'll explain that in a minute. So basically that's where we are. So we've covered one topic, CNNs. I will come back to this topic, in a while, and then we'll continue, going over all the other topics through this medium. I'm still learning how to use Zoom, but it looks pretty great. So I think this will do really well as a tool. So with that, before I start talking about the midterm, let me see how many people have. So there's about 5 participants, about half the class. I know some students are already like in Europe and Asia, so they may not be able to connect at this time, but I will be posting the videos for them. All right, okay, so someone else. All right, so as I said, I'll be posting the videos on YouTube, and we'll be using Zoom, check Blackboard, and the website. So before I start talking about the exam, are there any questions that you guys would like to ask at this time? Can you guys hear me?
Yes.
So you don't have to raise your hand. You can just talk. That's funny. Sumendra, you were something?
Yes, Professor.
Please.
Actually, Professor, I was worried about the meeting that we used to have on Thursday. So.
Oh, so this is about like meetings related to your research, not about the class?
Yeah, Professor.
Yeah, well, I'm gonna have office hours, so I don't know if you saw in the Blackboard. I'll have this. That doesn't work for you?
Yeah, it works for me. So just I want to make sure like I can just log into any time during that session.
Yeah, it's so the way that this Zoom works is that you just create like one link, and it's like a classroom. It's like an office that's open, so you can just connect to it whenever you want. The question is, will I be connected also? So
Yeah.
I'm setting like a schedule, so that way it's like I'm in my office between these hours, and you can just show up. Does that make sense?
Okay.
Yeah. So, but definitely email me. So yeah, as I'm getting better with this, I'm adding more hours to it. So today today I'm gonna assign you guys your take-home exam, which is not going to be trivial, right? And so you'll be busy with that. And then I have a class at 6, and then tomorrow I have classes 2 to 6. But usually on Thursday is when I have that whole afternoon open. So if that works. If you have something pressing, obviously you can email me and we can schedule. So it can be office hours or by appointment, right?
I will send you an email, Professor,
Okay,
regarding
that's
the
great.
exact schedule for
Sure,
the.
no problem.
Okay, thank you, Professor.
Yep. Any other questions, guys, about anything? Can you guys hear me? Can you just say something like, I can hear you?
Yeah, I can hear you.
Yeah, that was, who was that, Mitch?
Drew.
Drew, okay. Who else is in there? Who else is there? Can you just, so who's there? Mitch, are you there?
Yeah.
Okay. Alam, are you there?
Yes, sir, I'm here.
Okay. Sumendra, Tiang Yang?
Yeah, I'm here.
Great. Nupur? You there? Okay. I think she's there. All right. So there's some people that may not be able to connect through this. So as I said, for them, I was asked if I would take roll call on these. I'm not. So I understand that, you guys have situations. So you don't necessarily, I encourage you to attend this, but you don't have to, I guess, but watch the videos, of course. All right. So there's no additional questions. Okay, so it seems there's no additional questions. So then let's.
Professor?
Oh, go ahead. Yeah.
Yeah. So I just want to ask why is this session for? Like, if you will do it every week or it's just for today? And
No, I'll do
why?
a session every day. So now that I have this Zoom thing, my plan is to do the class. I'll record the video at the same time as I'm doing the class. So your questions will be in the video, but it'll be from 12 to 3 o'clock as we did before.
Okay.
Any other questions?
No.
All right. So those, hopefully that addressed your questions. If you have any further questions, please email me. All right, so now let's talk about the exam. So let me. The exam. So this is your midterm. Midterm exam. So the midterm is actually pretty simple. All right, so it's pretty simple. It's going to be a take-home exam. Take home. Okay. And I'm going to give you 1 week. All right, so a little less than a week. So it'll be due on Monday at 10 p.m. Okay, for this exam, you'll have to submit, it's one single problem, and you'll have to submit a report and a SIP of your code, right? Of your code, and the report should have screenshots, so I know what to look for when I'm grading it. But I will be running your code. Okay. Now you need to provide, as I said, your code, any data, etc. Okay. So those are kind of the parameters. This is an individual exam. Individual exam. Okay. And you can start it. It takes me usually a couple of hours to get the video posted. So I will post the description, all of these details, these slides, plus instructions on Blackboard, plus the video in about an hour or two, as soon as the video is finished. But really, there's not much that I need to give you for the exam and except the instructions. So, it's very difficult to create an online exam, right? So especially an online exam that's valuable to you. So it's not like a written exam, that doesn't help out at all. So instead I decided that I was gonna give you a problem. So I'm gonna give you a problem and I want you to solve it. Now, some additional recommendations. Please, please make sure, you know, that it is your own code, all right? So make sure it's your own code. If I read the code and I don't understand, or if I notice things that, oh, this looks like something that was from some other place, you know, found online, then I'm gonna have to have a session with you so that you can explain everything to me, because I may not understand what's there. If you use all the code that I provided in the class that I've explained, I understand that, so it'll be very straightforward for me to grade it, okay? So please definitely use your own code. You can use libraries. Well, we have someone else. So you can use, you can use libraries. Are you guys seeing this fine, guys, by the way?
Yeah.
Okay, you can see that I'm writing. Okay, great. So you can use libraries. That's okay. What I'm saying is, just please don't just like, oh, here's the question he asked, and here's the code and a blog, you know, a blog description of it. Boom, and it runs. I don't know how it works, but you know, don't do that, please. Because what I want you is really, I want you to get something out of this. Okay, so I rather you don't do so great, but all of it is your work, and you actually pushed yourself at least a little bit to where you learn something. Okay, so those are basically the, you know, those were my concerns with this type of a take-home exam. Okay, is that yeah.
Professor?
Question. Yeah, go ahead.
Yeah, I just want to ask that you said your own code. What do you mean by that? Like we have to write our
Say that
own
again.
code?
Sorry, I didn't. What?
I'm asking that you said that we have to write our own code, right?
Yes.
So like you have already wrote all the code. So is there any like we can use your code and make
No,
the,
right. When I say write your own code, I mean the code that I've given you. Yes.
okay.
What I mean is, don't just find. Okay, so for instance, so some things, you know, you will undoubtedly search this online, right? So I know you're gonna do that, and I'm sure you're gonna find a solution that uses Keras. I have no doubt that you will find at least one solution that uses Keras. For the purposes of this class, you know, I don't use Keras. So for this exam, you know, you can't use Keras. Do you understand what I'm saying? So that's what I mean.
Okay.
Alan, is that you can use everything that you've learned in the class. You can use my code, anything that's on my GitHub, no problem. However, none of that code that's in my GitHub will work immediately or right away. You have to modify some of it.
Oh, okay.
Make sense?
Yes.
Okay, and you can use some library, that's fine, you know, for like manipulating images or things like that. You just cannot use Keras, for instance. You cannot use, just like I found this code online, here's the folder with the images, it does the processing, I'm done. Make sense? Instead, I need you to understand everything that you've done and explain it to me, okay?
Okay.
Yeah, that's all I'm saying. It's fair, I think. You won't get anything by.
Like we used to do all the homeworks.
I'm sorry?
Like we used to do all the homeworks.
Yeah, it's kind of like a homework. I mean, it is like a homework. I've given you, you know, some code, and then I ask you, now apply it to MNIST. You know what I mean? It is similar to a homework, yes. It's an example.
Okay.
Got
Okay.
it?
Yeah, thank you.
Okay, great. Any other questions, guys? Okay, so another thing you can do is you can ask me questions about the exam. That's perfectly fine. So, you know, you can run code by me. You can, you know, obviously don't just say, hey, how do I do this? You know, maybe have a solution, and then maybe I can help you if you're having problems with it. So that's the idea. All right, so it's a take-home exam. You have about a week, so it's due Monday at 10 p.m. because next Tuesday, I need to start a topic called RNNs. And so, we got to be done with that exam. And then, as I said, you'll submit a report with screenshots. a zip file with code and data. It's an individual exam, not in teams or groups. I still need to talk about the problem, and then it has to be your own code. You can use okay to use my GitHub. Okay to use my GitHub, but you can't use things like Keras or some other thing. Okay.
Okay.
So now let's talk about the problem itself. So let's talk about the problem itself. So it's pretty simple. It's actually, it's a lot of what we've done in the class, right? So most of the class we've dealt with MNIST, right? And we've done logistic regression, neural nets, deep neural nets, and now it's the topic of CNNs, which is those videos. If you haven't seen those videos yet in the calendar, look at them. My code is on GitHub for that. That should run right away. So basically what I want you to do is pretty straightforward. Each of you will find, so I could have, I want everyone's assignment to be a little bit different, to kind of keep it, everyone has his own unique challenges. So the best way to do that is, instead of giving you one data set, each of you will have to find a data set. So the first thing is find a data set. A data set of labeled images. So this is going to be a supervised learning problem, okay? So it's supervised. Okay, so what you have to do is you will find a data set of images. Now, in the CNNs lab and in MNIST and in everything, in logistic regression, NNs, everything that we've done, the images have always been black and white. In this challenge, this exam, you have to adapt the code to work with color images. Color images. So I'll talk a little bit about that, but that's basically one of the challenges. So you have to now have a data set of color images. Remember that for deep learning to learn, you have to have at least 100 images. So I'm pretty sure you can find lots of data sets out there of color images. It can be 2 labels, 3 labels. Don't make it too many labels is my recommendation. So remember that when you're dealing with black and white images, you only have, like MNIST is 28 by 28 by 1, right? Because there's only one grid. But in color images, you end up having 3 because its color is determined by RGB. So you actually have 3 independent grids. So you end up with basically a cube of images. So this is going to be now 28 by 28 by 3. And sometimes these images, depending on if you're using JPEG or PNG, they can have additional layers. Like they can have a transparency, and that transparency then could actually be then that it means that it's 4. So what I'm saying is you might get confused. You might expect logically, no, but this should only have 3 layers and it's not working. Why? Well, because sometimes they do have RGB, and then they might have a transparency, a background, or something like that. A water art, right? And so they may have different kinds of things. And so that's why it's important that you, when you look at the images, don't make any assumptions. This value can deviate based on whether this is JPEG, JPG, .png, and so on. And a library that works for PNG or code that works for PNG it may not necessarily work for JPEG. Does that make sense, guys?
Yeah, but Professor, one more question.
Yeah,
JPG will have 4 layers or 3 layers? Like if we see the
I'm not saying, you have to figure it out. You have to figure it
okay.
out. I will provide, so I'm going to give you in a second some code just to give you a little bit of intuition into that. But that's part of the exam. It's figuring that out. That's one of the more challenging parts of the exam. Okay?
Okay.
So the exam is actually pretty straightforward. Everything except this part, I agree, it's a little bit challenging. So you'll have to figure it out. All right, but that's the one of the requirements. So you will need, each of you needs to find a data set, an independent data set of your own, which means that, you know, it's not going to be 28 by 28, right? It's going to be whatever your dimensions are, and it's going to be definitely color images. Okay, so you have to account for that. All right. Any other questions about the data set before we move on? Make sure that the images are labeled, right? So I'm just giving an example. Let's say it's color images of cats and dogs, right? So there would have to be a class for cat and a class for dog. Any other questions? Guys, no questions?
Professor, one more thing.
Yes?
Like how do we search this kind of data set? Like in which category will it fall? Like what?
Kaggle. You can go to Kaggle to look for data sets. You can probably find some there.
Okay.
Or anywhere, like you just change, you know, just look for image data sets, but a lot of the links will probably point back to Kaggle.
Okay.
All right, but I leave it to you, as I said. Now, do you need a data set that has 1 million images? No. Right? I understand you have limits in your processing power, so just find a small data set. You know, 1,000 images, 500 of each would be great. But the one requirement is that they must be color images, because I want you, one of the biggest challenges in this exam, and one of the biggest challenges really in deep learning, is getting those dimensions right? So that's really what I want you to focus on. Does that make sense?
Right. Yep.
Any other questions?
No.
Questions? All right. So you have the data set, right? And once you have the data set, then you're going to do, so when you have the data set, you don't, with the data set, you don't have to do any, you know, just because it's deep learning, right? You don't have to apply filters or anything like that to the images. You feed the images raw. All right. Now, once you have the images, you need to train with logistic regression. You need to train with a neural network. You need to train with at least 2 deep neural networks. Maybe I'm just, you know, giving you an example, like 2 layers and 4 layers, something like that. Right? So we'll do that. And then finally, you need to train it with a CNN, which is the topic of last week. So you need to look at the videos, basically. You know, the videos, I hope they were very clear. And of course, if you have any questions, let me know. The code is on GitHub. So I've given you the code for logistic regression, NNs, DNN, 2 layers, DNN 4 layers, and CNN. So you have the code there. The only thing is you have to adapt the code to fit this new data set, your new, you know, color images data set. Now, I had one question online that whenever you have images, do you still need to convert them to CSV? You know, because we always, whenever we did everything in previous examples, we would read files as CSV, load them into memory, and then, you know, slice them and everything. So yes, all of that applies. So the best approach, I would say, is, now do you have to take the images, convert them into an actual text file that's a CSV, and then read that in? No, that's not necessary. You can do everything in your code. So you can write code that takes the color images, let's say from a folder, and just immediately starts creating a matrix that is in the format of CSV, right? And then you can do all the slicing that's necessary. You want it to be a NumPy array. And then from there, you can feed it into all the classifiers just like we've done before. Are there any questions about that, guys? All right, so it seems like that's clear, so great. All right, so now there's two things I want to show you. So you already, you already have this code, this code, this code, this code, and you have this code, but I'll point out where it's located. And then I want to show you also an example I have of how to deal with images. Now, the example I have online only deals with black and white images. So you will have to, you can maybe start there and possibly modify it from there. Okay, so that's it. This is your exam. At the end, the result of the exam, and everyone hopefully, please, needs to have this, is you will have, the usual thing, right? So you will have precision, recall, accuracy, F1 measure, right, for all your methods. So you're going to have, logistic regression, you're going to have neural network, you're going to have deep neural network of 2, you'll have deep neural network of 4, and then you will have a CNN. Okay, so you'll basically plug in your values here and then do a comparison. And you need to include also the confusion matrix for these methods. So the confusion. So in essence, I mean, if you think about it, the exam is not really that difficult. I mean, obviously it has some challenges, but it's something that should be very consistent with what we've been doing this semester. The key element in deep neural networks is understanding those tensors, understanding how to manipulate tensors, and nothing will make you better at dealing with tensors than dealing with images, right? So if you do this exam successfully, you will actually, it'll make you really good at dealing with the tensors themselves. All right. So any questions, guys? Any other questions? No? All right, so then let's move on to, hold on. All right, so I will post these slides and I provide a description, as I said, this video on the websites. Remember, this website is what I'm using because of the calendar to keep all the videos. I added, this is a video that we didn't cover in the class, but I had done this video for another class before. It's a video on deep neural nets, but it's another video that I did. And because I had no recording of the actual lecture I did this semester, I added this one. And it might actually have additional things. So I recommend, if you have time, take a look at it, because it's actually pretty relevant. For whatever reason, in this video, I talked a little bit about the intuition of CNNs. And so it might be useful to you. After that, make sure you look at these two videos of CNNs, okay? This is where I explain everything on convolutional neural networks. And it's coming from my book pretty much, but take a look at that one as well. Now, all the code is on the GitHub, so we can go there. Go to the GitHub, and I want to point out two things. Okay, so the first thing is I want to point out that all the CNN code is here in convolutional neural networks. You can see that there, right? And play around with code. Okay, so take a look at that. Just run it on your computer. It should, run without issues. Now, as far as the images, I have posted here an example. If you go, can you guys see what I'm doing? Guys?
No,
Yes.
no,
You guys can see that I'm going through GitHub and everything?
no. You are not sharing
No.
that part.
Okay, all right. I wish some, yeah. All right, so you're not seeing, I have to do some, sorry. So what did you see last, the slides?
Yeah, it's the slide. Still on the slide.
Okay, hold on. All right, so I was saying, what do you guys see now? Do you see the website?
Yeah, the GitHub and the website.
Yeah, so if you go to the website, as I said, there's this video, which is an old video from another class that I taught, but it's on deep neural nets, and I actually talk a little bit about filters and the intuition of CNN. So I would recommend that you take a look at this video, and then after that, make sure, if you haven't done so already, to look at these two videos on CNNs, convolutional neural networks. Okay, so this is that topic. Once you do that, all the code is on GitHub, so you can click on the GitHub. You can see now I'm on the GitHub, guys. Can you see I'm on the GitHub?
Yes.
Okay, great. So then once you're on the GitHub, all the code is here. This is the code for the semester. There's the scripts for convolutional neural networks. Okay, so you can take a look at them. And then the last thing I want to talk about related to the exam is what's in this. So I have, so one of the requirements of the exam is that you have to convert the images, right? So in this folder, GANs, I have put some examples here of PNG images, right? So these are PNG images, okay? But they're not colored, they're only black and white, okay? So if you use this script called GANs yourimages.py, click on that. And now in here, I have provided a section. So you can ignore most of this code really, because all that you need is the section on converting the images. So I have in here, if you notice here, right, from here on, I have added some code that will allow you to create your own data set, like your own MNIST. Now this code only works for PNG images, I think, or at least because PNG images have a certain format. It might work for JPEGs, but you just you will have to adjust the way that you process the images. Does that make sense?
Professor,
Yeah, go ahead.
like after running this code, how can we say that our images are properly transformed into CSV?
That's a good question. So here's what I would recommend. You don't need any of this code, right, except for this part. So copy this out into like a simple Python file, right? The code runs, I'll show you. It runs from basically from here, all the way to about there, This part of the code assumes once you've created the matrix that you normalize it. So that's all it does. That's the normalization. Now on here, you basically take a library, and in this case, I'm using pill from image. Now there are other libraries. Okay, so this is just one of many, many ways of doing this. This could be a lot easier maybe if you did it in pandas. Okay, so as I said, I leave it to you to do it. The simpler, the better, okay? So you'll use all these libraries. you will read your images. If you notice here, this line of code is reading the images from a folder called test A. I provided the test A files, at least some of them, on the GitHub, so you can just try this out first, see that it works for black and white images. All right, so if you notice, all you do is you iterate through all the images, and here, notice, this actually intentionally converts the images to black and white, so it does have the power to have color images. That's possible. You just have to figure out how to adapt it. After that, everything that's happening here is basically slicing, right? That's all you're doing. You're basically reshaping things. So notice you're slicing here, or using shapes, or you're using the function reshape to change the shape of the image. Does that make sense? So for instance,
Yeah.
if the image is, I don't know, I can write on here. I don't think I can write. That doesn't work. So what I'm saying is, if the image, if it reads something that is 28 by 28 by 4, okay, you need to make it 28 by 28 by 3, and then figure out how do you make that, you know, how you flatten that, etc. So that's one of the challenges of this exam. Do you understand?
Yeah. And Professor, where
Once,
this
hold on.
program,
One issue. Once you have the image, you create a data set like this one, train. So if you notice, train is a list. So in this list now, you're appending all the images. And then once you've appended the lists, the images into the list, notice here, you make it into a NumPy array. And that's it. That should answer your question of how you make this into CSV. Because once you just take the images, make them into like arrays, put them in the list, and then you make it a NumPy array. And now train is literally your array. From there on, you can, you know, this code, for instance, that I provided here should give you a little bit of insight if you were dealing with color images, right? So that's there to help you. You notice it's just commented out. So it's there, you know, in case you had color images, then how do you deal? And usually the images are called channels, by the way, okay? And then finally, you can save it. So this will save it as a NumPy array. You can take this array and make it into a pandas data frame. And once you make it into a pandas data frame, pandas has a function called print as CSV. It'll literally print out your CSV file as a text file. You understand, Alan?
right? Yeah. And Professor, where this code is ending, like from
Say that
where
again,
to
sorry?
where this code is ending.
Where
Like,
does the code end? Okay, so this code that I have here is part of another topic called GANs, but you're not doing GANs, right? So all you need from this code is from this line here, all the way to this line here. This is the normalization. So you might as well just use this code to normalize your images or your data set.
okay.
But basically, I guess to answer your question, if you notice, if you were, so I made this consistent. So for instance, usually in the code, the MNIST data is called MNIST, right? You have MNIST and then you have the MNIST object as a NumPy array. So here I just called it your MNIST. And that way that kind of tells you, oh, that's the variable that would replace the MNIST variable.
Okay.
Okay. Yeah.
But you name it as a train, so it will be the whole data set. It's not train. We have to
Right,
it
it can be the whole data set. Yes, it can be the whole data set, and then you can do a train test split, or you could have, or not. I mean, just repeat this for the test set, right? The thing is, for this one, this is an unsupervised problem, and that's why you don't really need train and test, but you could. So what you could do is you could write two functions, right? And both functions kind of have the same code, except that one is for train, one is for test.
Okay.
Make sense?
Yes.
Okay, that's it. I mean, guys, this is the hardest part of the exam, in my opinion. And then you need to apply it to all the algorithms, logistic regression, and then two deep neural networks and the CNN, and report your results. There might be a little bit of challenge when you load the images into the CNN. The CNN requires that some dimensions. Again, all of this is about making sure that the dimensions of one layer are consistent with the dimensions of another layer. Okay, so but once you have your data set, it should work on all algorithms.
Sir,
Yes.
if we already have a data set it's converted into CSV format, do we have to find a data set with raw images, or we can use
cannot do
directly as a
that.
CSV
You
format?
can't just find a CSV
Okay.
and use it. That's not the exam.
Okay.
The exam is, if you do that, then just doing what we've done in the class before, right?
Yeah.
The exam is, I mean, it's supposed to be challenging, right? So the exam is, you have to take as input color images. Do your best. I mean, enjoy it. You know, don't take this as a scary thing. Take it as a fun thing. Enjoy it. If ask, if you want to run code by me, and I will help you. Right? So I will help you along the way, but take this as an opportunity to learn something new.
Professor, I have a question.
Yes, Sumendra.
So can we create our own data set in that case?
You want to spend time creating your own data?
I mean to say, we don't have to prove it like for hundreds of images, right? We can still...
No, it doesn't have to have, I mean, as long as there's enough for the algorithm to learn. Remember, you have to have a train set and a test set, right? So if you had 100 images, that's only 30 tests, 30 images. If you do 70-30% split, right? So you can't, I mean, there's no reason why you cannot create your own data set. I just think you'll be spending a lot of time just on that.
Okay, because it's a supervised. That's
it's
right,
supervised. It is supervised, so you must have labels. So the example is cats and dogs. So you have, let's say, 500 images of cats, 500 images of dogs. They're labeled. Remember, it is very important. I'm going to go back to the slides here. It is very important that the dimensions of the images are all the same, okay? Remember, in MNIST, all images are 28 by 28. If you did something like what you said, I'm going to get some images, and one image is 50 by 24, and then one is, 28 by 28, and so on. That's not good. They all have to be the same size, okay? You'd have to resize them. I would not recommend that, actually. Your algorithms, it'll perform worse. So usually, whenever you do things, you want the images to be the same. And it's something that, like with a camera, right? So you had a camera and the camera never moved and people were always standing in the same place, right? So it basically, the proportions are always, do you understand?
Yes, Professor, I got it.
Yeah, so this is definitely a no, right? It's a nightmare if you do that. Make your problem, so it's already hard enough, is what I'm saying. Don't make it even harder by having to deal with something like this, right? So for this exam, find images that are same dimensions, pretty, cats and dogs, right? So, you have some image of a cat, right? You have a cat there, right? And then you have images of a dog, something like that. Okay? It can be fruits, it can be apples and oranges. If it's that, color images are going to do really well because apples are red and then oranges are orange. So color here is actually very useful, okay?
Yes, I got it, Professor. So it's supposed to be in a PNG, JPEG
It
format.
doesn't, the example I provided is PNG. That code, I believe, also handles JPEGs. It's your choice, but they should all be the same pretty much so that you're not dealing with, oh, these are PNGs, have this structure, and then these are JPEG. These, you want to simplify it. Now, as I said, there are libraries that do a lot of this. So, and that's okay. I'm okay. Like if you find a library, my example was meant to kind of do it manually. Does that make sense?
Yes, Professor, I got it.
It's meant to kind of show you the dimensions, but you don't necessarily have to do it that way. So the things that, so as far as what I'll be looking for, obviously a lot of the, if I just gave you a CSV and I tell you to use a neural net, I mean, you pretty much know how to do this from all the homework. So that's not really where I'm focusing my attention. My attention will be focused on, the data set. That's really the challenges that I want you to solve. Data set, let's call it the CSV, right? So you know that because everyone, you think that, So this is the, very important part. And then also, I want to see how you do with the CNN, right? So the CNN, you haven't done a homework yet. So I want to see if you can take everything that you've learned from all of these and apply it to the CNN. So the CNN is very similar, as you'll see in the videos. It's just that because the code I gave you for the CNN was for 28 by 28 by 1. That's what it handles as input in the code. This time around, your code will be, let's just say, 50 by 50 by 3. And that little change will require you to adjust the code. Does that make sense? Not too much, but a little bit. I mean, there's like a little trick, but you kind of have to figure it out. Is this clear, guys? So these are the things where I'm focusing a lot of my attention. So 3 things basically: that you can take a data set and convert it, color images, and convert it to CSV. That's 1. 2, obviously, that you can apply the CSV to all the algorithms. I expect everyone to be able to do that easily. And then 3, that the images are now, instead of 28 by 28 by 1, they're 50 by 50 by 3, and you have to adjust it to the CNN. So those are the main 3 things, so I can write them here, like the objectives of the exam, right? So objectives of exam. So they are color images, CSV on logistic regression, NN, deep NN, and then finally, color images. This is also color, so I don't want to color CSV. Color CSV on CNN. And I guess finally also that you still know how to analyze the performance metrics. So F1, precision, recall, etc. So these are the objectives of the exam, okay? And so
You're still on the GitHub.
Yeah, sorry?
I said you're still showing the GitHub if you.
Oh, really? I've been writing for hours. Oh my God, sorry. sorry. All right, I'll repeat it. Oh, I'm sorry. Okay, so what part did you not? You saw that. So you understood this part, right? This is where I was talking about how the images, make sure that the images are not like 50 by 24 and then 20, they should be all consistent, right? So you all got that part?
Yeah.
Drew?
Yeah.
Okay.
Yeah, I got that.
Yeah, all right. And then what I was saying here is that the main 4 objectives of the exam are these, right? So that you can process color images, take PNGs or JPEGs and make them into CSV, so this part. That you can process color CSV on logistic regression, NNN, DNN. This should be easy if you've done this already. And then that you can also apply the color CSV to a CNN, right? So the example I provided in the videos is a CNN that only deals with black and white. So what I'm saying here is the CNN in the example, it only processed 28 by 28 by 1 as input, but now your input might be 50 by 50 and definitely by 3. So that will require you to make a small tweak to the CNN architecture. And then finally, that you can do the analysis of precision, recall, F1 measure, and so on. Does this make sense, guys?
Professor, when we use,
Yes, sir.
we will be still using the CNN filter and max pooling lab, or?
Yes, you will use the code that I provided pretty much as is. You can use, you don't need, so I think your question is, do you need to add more layers to the CNN, right? So you don't. You can just use 2 layers, 2 convolutional layers. Every convolutional layer always has the convolution and the max pool. What might need to change though is the dimensions, okay? If your images are, you know, bigger, slightly bigger, you might need to, so that's really where the work of the exam is, in figuring out how to change that architecture.
Okay. So because I was confused because I used the max pooling and the CNN for the denoising autoencoder earlier. So they have an architecture in there because when we feed our images.
Oh, you use a CNN already in an autoencoder, you're saying?
Yeah, I just use their filter, and
But did you perform a convolution and a max pool? Is that what you're saying?
Yeah, that's why I'm getting confused, because I use their filter for my architecture. I just use it for a single hidden layer.
Okay, so that's fine. I mean, what you did is you took an autoencoder, and by adding a convolution and a max pool, you just made it a convolutional autoencoder.
Yeah, with a denoise.
Yeah, that's fine. That's what you did. I mean, you can. So I guess I don't understand your question. You can use things from CNNs, like, oops, sorry. You can use, you guys are still seeing my slides, correct?
Yeah.
You can use things from CNNs in other algorithms. That's perfectly fine. So the only thing that makes a CNN is the fact that you have a convolution operation. So that means you don't have a mat mul. Instead, you have the con2D.
Yeah.
You have a max pool.
Yep.
If you notice, the other thing is just the fully connected layer or the input layer. So
yeah, those are the filters, right?
It's just that. Say that again, sir.
Those are the filters, right? Because we have.
Yeah, exactly, Sumendra. Exactly. So in a convolution, so any network doesn't matter how many layers you have, right? You have layers, whatever this is. It's not a CNN until. So if you're always doing mat muls here, right? You're doing mat muls. But if you add a layer, and the layer has, instead of a mat mul here, a convolution, right? That makes it a convolutional neural network, because now the convolution is not just a simple multiplication. It is basically applying the filter to the previous layer. And then the max pooling operation, literally all it does is it cuts this input in half. Whatever this input is, it cuts it in half. So whenever you add, instead of mat mul, a convolution, you just made whatever this is a convolutional technique. Do you understand?
Yes, Professor. That's what I did. Actually, I added a noise and then I used convolutional filters to
Yeah.
denoise the image for the autoencoder. That's how I train my autoencoder.
Well, great. All right. So, and that's really all you have to do. It's whenever you know, as I said, you have layers, layers, layers. Remember, the operation here is matmul, right? It's always matmul. But when you have a convolution, what happens is you can think of the previous layer as an image. The weight matrix is actually small, and you apply this filter across the object, and you're modifying it into another object. So that's what makes it a convolution. Just that. Did I answer your question, Sumendra?
Yes, Professor. Yeah.
Okay. Are there any other questions, guys? Guys, you still there? All right. So let me just go by. I'm not doing roll call. I just want to see. Tiang Yang, do you understand? Sam? Tiang Yang, are you there? Okay, he doesn't seem to be there. Mitch, are you?
Yeah, I'm here, but
If 1 hour.
Yeah, I'm all good.
Okay, all good. All right. Yes. Is someone asking a question?
Yeah, I'm just asking, can you do an overview of CNN code? Because what I saw on GitHub, like it was, I found it little bit changed that you explained in the video. So
You think it's different somehow?
yeah, like I think I was little bit confusing over the code. So you said you will write the code in the class before the exam. So will you write it today?
Hold on. Let me take a look at the code.
We cannot see your screen right now.
Yeah, hold on. I'm looking for it. Hold on. All right, so all right, so let's see. This is the exact same code, Alam. I'm not understanding.
Go over convolution layer.
It's the exact one.
Go up a little bit more. Yeah, more. Keep going.
Keep going.
Yeah, this one and okay, so this is for the accuracy score and the other things. Okay.
Right. These two functions are the exact same functions we used in previous code examples.
All right.
Is that where you were confused? This doesn't really have to do with the CNN. This part is not.
Okay. And what is this?
What this one?
Over it. Lower. No.
This part here?
No, upside.
Even more, you mean?
Yeah, this.
Oh, that function. That function is if you have build data from MNIST. So you want to create CSV files from the MNIST. So instead of just reading the data set directly into your code, you can just take it and generate actual CSVs. And then the CSVs, you could then read them back again. You can see that it says create CSV files from MNIST.
Okay.
It's not being used. I mean, it's just a function that I have in there, but it's not actually being used.
All right.
So your question was about,
Yep.
so definitely run, I mean, this is the exact code in the videos. I mean, I can go over it again. I mean, but it's literally the same one. Has anyone tried this code, running it, guys?
No, I haven't tried it yet.
You haven't tried it? Okay, so definitely try it. If you're having issues with it not running, then definitely let me know. I'll take a look at what the error is, but it should run. And this is, so there are two scripts in this folder. There's this one and this one. This one is the modular. So the one that's a CNN modular book. So that's the script that I went over in the video. So you can see it's the libraries, right? And then it's got the learning rate, the number of epochs, the batch size, which is 128, right? Display step is just when it prints. Number of inputs, it's MNIST. Number of classes is 10. I talked about the dropout in the video. It's basically just a little technique that sometimes you may have a lot of connections in your network and you just decide to drop 25% of them and force the algorithm to learn with less. Right, so that's the idea. It's really just a parameter that is passed to a function at some point. You can basically disregard this. This is not being used. Here, you just read the data, right? Already one hot encoded. And so in this example, instead of reading the files, I use the MNIST iterators. So that's one of the challenges of the exams, right? You will have to adapt your code now to read images from the image folder. Does that make sense? Guys? Can you hear me? You're seeing this, correct?
Yeah, Professor, yeah.
Yeah, sir.
Okay, so as I said, print stats metrics is just a function we did before. Plot metric per epoch, that's just a function we saw before. I explained in the video that before, the operation that does all the heavy lifting in deep neural networks is matmul, a matrix multiplication. But in convolutions, you don't do that anymore. Now you do, instead of matmul, you use the operation con2d. So if you notice, this function takes, notice here, instead of this being matmul, it is now con2d. It takes the x times the w. Just like before, matmul took the x times the w, con2d takes the x times the w, right? And it basically takes x and it modifies it. But the idea with convolutional neural networks is that it's a different operation. So I described in the video what a convolution is. A convolution is like a multiplication with constraints. Or another way of viewing it is like, imagine that you're sliding a tile or a window through an image, right? So you have like, you know, like imagine this is the screen, right? So you guys can see the mouse, I think. So I'm gonna take this pixel and I'm gonna apply to it a filter that just looks at the pixels around it and averages it. Then I move to the next pixel. And I apply a filter that basically just looks at all the pixels around it and averages that value. And then I move to the next pixel and I do the same. Do you guys understand that? Guys?
Yeah, Professor.
Yeah. All right. So that's the operation. Look at all three videos. So I went over that in a lot of detail on the videos. If that doesn't make sense, you know, please ask me again. Really, what I want you to do is run this code on your own.
Yeah, Professor, I have one question. We can use different activation functions, right? Instead of ReLU. We can.
You can, yeah. Why not?
And we can play with those loss functions too, right, Professor?
what do you want to do to the loss function? Wait.
Because when I submitted my homework last time, so I played with different activation functions, the loss, because there
Yeah,
is-
you can, different activation functions, you understand that all they do is they convert from 0 to 1, you know, that's perfectly fine. But what are you going to do to the loss function exactly?
because I saw the way it learns and the loss is a really big difference. The image is, the way they input the image, the format, the texture, it's all different based on the activations, and the learning curve is.
So what other loss functions would you try, I guess is my question.
Binary cross entropies, MS.
Oh, okay, so you would change this to a binary, instead of a softmax, you're saying like a binary cross entropy and so on.
Yeah, Professor.
Oh, that's perfectly fine. I mean, I encourage that. At the end of the day, this is your solution, right? Your architecture, and you just, you know, you'll show me the results, right?
Yeah, Professor. I was just like concerned, like do we need to use, because sometimes like
You need
these
to what?
images behave different when we use like different activation functions.
No, that's fine. What I recommend is, and this is very important, please don't just find some code online and, you know, hey, here's the solution. It already has a data set and it works. Instead, the code needs to be familiar. So it has to be familiar to the code I've given you, so that I know that you're building on top of that code. I'd rather you have something that's not so great, but you did all of it, than you have something so amazing, but you can't even explain it. You know what I mean?
Yeah.
Yeah. So as long as you're definitely play with all of this for sure. Are there any other questions, guys? So let me go. I guess sometimes some of you are shy, so let's just see. Tiang Yan, any questions?
Nope, I'm good.
You're good. You understand the exam. Okay, Drew,
I think I'm good for now.
you think you're good? Mitch,
Yeah, I'm good for now.
right? Jusong,
I understand.
you understand? Okay. Sumendra,
I'm good, Professor.
okay. Joe,
Yes, I think so.
Joe.
Yes, I think so.
Okay, great. You think you're clear? Ruiling Wang, are you good? Okay, I think he said something there. Nupur,
Yes, so
everything clear?
yes, it's all clear.
Okay, excellent. All right, so I think that's everyone. I know we're missing some people because they're traveling. I will post this video on Blackboard. Sorry, on the calendar. So you will have 4 videos to look at if you haven't done so already. Have the code on GitHub. Find a data set. Please, everyone, have your own data set so you have your own set of challenges. Again, you can use pandas to process the images. That's fine. Just make sure you understand everything you're doing. To me, the simpler, the better. So, but definitely make, when you're dealing with the image, one advantage, let me give you this clue. One advantage of dealing with the images is that you're not dealing with tensors yet. You're doing all the processing of the images outside of the computational graph, which means it's just like regular programming, right? You can print out the dimensions, and get a better understanding of what's going on. Does that make sense, guys?
Yep.
Professor.
Yeah. So now, one last thing. Okay, so I have to share. Let me go back to the slides again. I just want to. All right, can you guys see my slides? Guys, can you see my slides? Hello?
Yeah.
Okay, so if you have a color, let's just say not even a CNN or anything like that. Let's say you're just doing logistic regression. Right, so this is an important thing. So when you had an image that is black and white, it was 28 by 28 and 1, right? So all you have to do is you flatten the image, right? So you basically flattened it, and now it was 784. Is that correct? That's all you did, right? However, now you have 3 of these. So what do you think you can do? Is my question.
I think 28 by 28 by 28.
It's supposed to be 28, 28 into 3, right? That's what I think.
Say that again, Sumendra?
It's supposed to be 28, 28 into 3.
Yes. So how would you do that? What would be one approach? I mean, there might be multiple. What's the simplest one?
We just have to go into the code and change the dimension.
Sure, but so what do you end up with? Right now you have 28 by 28 by 3.
So we will have 3 images.
You have basically 3 grids of 28 by 28. That is correct.
So the output will have 3 layers, and like we have to multiply 28 into 28 into 28, right?
Anyone else want to try?
Is it like 784 into 3?
Yes. So that's the simplest idea, right? The simplest approach is you make 28 by 28, 784, but then there's 3 of these. Do you see that? So you end up with one single vector of what size? Of
2-dimensional, right?
yeah, what's 784 by 3 is
2352.
yeah, so 4 times 3. Yeah, 2352. Do you see that? And then this vector can feed into the logistic regression, just like you did the other things. And every image, the first set will be the R, and then the G and the B, right? So it's always looking at the same area. So that the great thing is it always compares the same area for every image. Does that make sense? This is not the only way of doing this. This is the simplest. Okay? There are other ways of doing this. But at least I wanted to give you one approach. Is this clear?
Yeah, Professor.
All right, great. So it sounds like it's clear for everyone. All right, so that concludes this video. All right, so this your exam. Consider your exam assigned. Okay, as I said, in a couple of hours, I'm going to process the video in about an hour, I think, or less. I will post a link to this video. I'll post these slides. I'll put a little bit of information on Blackboard, but basically this, this information, right? So your exam details, again, it's a take-home exam, due Monday at 10 p.m. You need to provide a report with screenshots so I know what you did, and a zip file of your code and data, or a link to your data set in Kaggle or something so I can, if it's too big. Remember, it's an individual exam. Everyone must download their own data set of images. Remember, it's color images. It's basically the challenge. And the problem is that color images and your own code. So again, I repeat, don't just use Keras. Do not download things online. It has to be, use my code and modify it. As Sumendra mentioned, play with it. That's perfectly great. But just, make sure it's code that you understand 100%. For processing, you can use libraries, things on my GitHub. When I say libraries, I mean like libraries that allow you to do image processing and things like that, but not Keras or someone else's code. And then the problem, as I said, is find a data set, supervised learning, labeled images. The challenge is because it's color images, it'll be instead of 28 by 28 by 1, it'll be 28 by 28 by 4 or something. JPEGs or PNGs, keep it consistent. You can search Kaggle, and then you will convert the data set to the CSV format that we've been using. You don't have to create the text files if you don't want to, just do it in the code itself. And then you will apply it to our logistic regression, neural net, DNN of 2, DNN of 4 layers, and a CNN. And then finally, you will present, you know, the accuracies and everything. All right, so that summarizes everything. So I'll give you one more chance to ask questions if you have any.
Professor, I have one
Yes,
question.
sir. Uh-huh.
So instead of RGB, if we use CMYK, it still works, right?
If it's color images,
Yeah, instead of 3, now we will have 4.
It's just a different channel. It's the same thing.
So it will still be working, right, Professor? We don't need to have.
yeah, it's, I mean, at the end of the day, Sumendra, at the end, so let me put it this way. Regardless of what format your images are made, what you have in there is information. See that?
Okay.
And all the information, if it's relevant, you want to use it. Do you see? So for instance, you know, one like crazy example, RGB. Well, it turns out that this doesn't have any red because it's outer space or something. You see that? So maybe even you don't need that layer, so get rid of it. But if CMYK or whatever layers you have, if there's information that's relevant in there, use it. So the example I gave you of PNG. PNG has this transparency layer, but it's transparent. It has no value to it, so get rid of it. So what I would say is think of all images that way, as just information in layers. Figure out which layers will be useful to you, keep them, and then the other ones you can get rid of.
Okay, right.
Does that answer your question?
Yeah, Professor.
Okay, great. Anyone else? Going once, going twice, sold. All right. All right. So hopefully you like this exam. I think, you know, I debated about this, but I felt pretty happy once I thought about it. So I think this will be a really fun challenge for you. And as I said, you know, we can even have an independent, like office hours if you'd like at some point. My goal is that you guys solve this. I want to see you guys, if you solve this, 100%, I mean, you're going to be pretty good. You know what I mean? So I want you to take it that way. Take it as a nice exercise to bring together everything that you've learned, right? And then we can move on next week to the next topic, which is recurrent neural networks. Remember, we will be meeting all from now on Tuesdays from 12 to 3 through this medium. So this seems to work really well, I think. All right?
Yeah.
All right, great, thank you. All right, guys, so good luck on the exam and looking forward to your submissions, okay?
Okay, Professor.
Bye.